Hi everyone, myself am Preetiram, working as an assistant professor in the Department of Computer Science and Business System in Ramco Institute of Technology, Rajapalayam. Today we are going to see about the topic FCOE architecture, that is Fiber Channel over Ethernet. It is a network protocol that allows us fiber channel storage traffic to be transmitted over the Ethernet networks. Traditionally, fiber channel and Ethernet have been two separate infrastructures. Fiber channel for storage network, that is we can mention as SAN, and Ethernet for local area networks, and we can mention as LANs. So FCOE converges these two onto a single unified Ethernet fabric. By encapsulating fiber channel frames inside the Ethernet frames, fiber channel over Ethernet enables us organization to use existing high-speed Ethernet infrastructure to carry both the data and storage traffic. This reduces the need for separate adapter switches and cabling for SAN and LAN, leading to cost savings, simplified management, and improved efficiency. So fiber channel over Ethernet does not change the upper layers of the fiber channel protocol. It preserves all the features like reliability, flow control, and data integrity. What changes is only the transport medium. Instead of traditional fiber channel cables and switches, fiber channel over Ethernet uses enhanced Ethernet networks. In the upcoming slides, we will discuss about it in a briefly manner. So, what is fiber channel over Ethernet? As we have already said, it is a converged network technology designed to carry fiber channels storage traffic over the standard Ethernet networks. It reduces the need for separate LAN, that is the local area network Ethernet, and SAN, that is the storage area network fiber channel infrastructures, by allowing both to share the same Ethernet physical links. In large-scale data centers, IT administrators face challenges such as high cabling cost, multiple network adapter, high power usage, and complex network management. Fiber channel over Ethernet addresses these issues by integrating the storage and data networking into one environment while still maintaining the high performance and reliability of fiber channel. Why fiber channel over Ethernet is needed? So we can split it into five parts. That is, first one is consolidation, then second one cost savings, then next one is a simplified management, then high performance and future ready. So first one is consolidation. Traditionally, data center used two separate networks, Ethernet for LAN traffic and fiber channel for SAN traffic. This meant double cabling, switches and adapters. Fiber channel over Ethernet merges both onto a single Ethernet fabric. So next one is cost savings. So it reduces hardware, cabling and power consumption by eliminating the duplicate infrastructures. Next one is a simplified management. It is easier to configure and manage one converged network instead of two separate ones. The next one is high performance. It leverages high-speed Ethernet while retaining fiber channel reliability and storage protocol features. Then the last one is future ready. It supports modern data centers where unified and scalable infrastructure is essential for virtualization and cloud environments. This is the main architecture of the fiber channel over Ethernet. In a fiber channel over Ethernet architecture, the workflow starts from the compute systems where servers run multiple virtual machines on top of hypervisors. Each server is equipped with an convergent network adapter, that is mentioned as CNA, which combines the function of traditional Ethernet NIC and a fiber channel HBA, thereby enabling both data LAN and storage SAN traffic to be transmitted over the same physical link. The CNA encapsulates the fiber channel frames into Ethernet frames and sends them through the converged enhanced network Ethernet. This enhanced Ethernet ensures a lossless high-performance transport by implementing features like priority flow control, that is mentioned as PFC, and data center bridging DCB, which are essential for handling sensitive storage traffic. The encapsulator frames arrives at fiber channel over Ethernet switch, which acts as a Central consolidation point. At this stage, the switch intelligently separates the traffic normal. Ethernet traffic is routed towards the local area network LAN, while the encapsulated fiber channel frames are forwarded to the fiber channel SAN, that is FCSAN. Within the FCSAN, the frames are decapsulated and delivered to an appropriate storage system through fiber channel ports. The storage system then processes the request and sends the data back through the same path, maintaining the encapsulation and separation mechanism along the way. This entire workflow allows us enterprises to unify their LAN and SAN infrastructures over a single Ethernet-based network, reducing cabling, lower costing, and improving manageability, and still ensuring the performance and reliability demanded by the storage communication. In the upcoming slide, we will detailedly see the each and every part of it. So the first one is the compute layer. So hypervisors and the virtual machines. Each physical server runs a hypervisor that hosts multiple virtual machines. Virtual machines generate application I/O and file system requests that translates to SCSI commands. The next one is virtual HBAs or vSAN adapters. Hypervisors present virtual host bus adapters to virtual machines, so each virtual machine can issue storage commands that look like a native fiber channel traffic. The next one is the converged network adapter, that is we can already see that CNA. Hardware installed in each server that implements the both NIC and HBA functionality in one devices. The main responsibility is to construct the fiber channel frames for SCSI commands coming from the host or virtual machine. Encapsulate those FC frames into Ethernet frames compliant with fiber channel over the Ethernet. Then the next one is the fiber channel over Ethernet switch and DCB fabric, that is the middle part of it. DCB enabled Ethernet switch provides us a lossless Ethernet fabric required for fiber channel over Ethernet to operate reliably. Then FCF, fiber channel forwarder, the switch or gateway that terminates the fiber channel over Ethernet sessions. It decapsulates the Ethernet frame to restore the native frameworks and register the host ports with the fiber channel SAN fabric so the host can communicate with the storage. The next one is the local area network connection. The same physical switch can also forward normal IP traffic to the LAN with traffic classes separated by quality of service settings, so traffic remains lossless. The next one is the fiber channel SAN and storage systems at the bottom. Fiber channel SAN fabric, traditional fiber channel switches and fabric services. Once frames are decapsulated by FCF, they transverse the fabric using the standard FC addressing, zoning and management. The next one is storage arrays with FC ports. Provides us LUNs and respond to SCSI commands. From the host perspective, these arrays look like an ordinary FC devices, even though the traffic between the host and FCF travel over the Ethernet. And what are the key protocols and control function? Let's see about it. FCOE encapsulation. So FC frames are encapsulated into Ethernet frames for transport. Encapsulation preserves FC frame structure and sequence semantics. So FCOE initialization and discovery. A control protocol is used for discovery and login, so the CNAs and FCF can find each other, discover LANs, VLANs or virtual links and register WWNs with the SAN fabric. The next one is DCB, that is the data center bridging. So it involves priority flow control, PFC. It passes the traffic per priority class to avoid the loss of storage frame during the congestions. PFC provides lossless behavior only for designated priorities used by the storage. The next one is ETS, Enhanced Transmission selection. It allocates the bandwidth across the traffic classes so storage can get guaranteed bandwidth without starving other traffics. And the next one is DCBX, a protocol that exchanges DCB configurations so host and switches agree or priority mapping and other parameters. Fiber channel fabric services like zoning and LUN masking continues to operate unchanged on the SAN side. So these are the real-time scenario that matches the diagrams. So consider a cloud provider hosting a multi-tenant virtualized environment with hundreds of virtual machines per physically server. Each tenant requires block storage performance for databases and virtual disk. Physical servers are equipped with CNAs, so each virtual machine storage traffic appears as a separate virtual ports. Storage traffic is assigned a high priority class in the DCP fabric, so I/O from the latency sensitive databases is never dropped. The data center uses a fiber channel over Ethernet switch with an FCF gateway to connect to a central fiber channel storage cluster. Zoning and LUN masking on the SAN enforces the tenant isolations. Network and storage administration manages one converged fabric rather than the two separate cabling systems, that reducing the cabling, rack space, and power consumption while preserving the SAN features such as zoning, multipathing, and the snapshots. This deployment closely follows the diagram, that is the virtualized compute at the top, CNAs per server, DCB enabled switch acting as an FCF in the center, and FC SAN with storage array at the bottom. So what are the protocol layer in the FCOE? The architecture follows a fiber channel to run over the Ethernet without redesigning the storage application. That is, the first one is upper fiber channel layers, that is FC2, FC3 and FC4. It handles the tasks such as frame formatting, flow control and SCSI command executions. The next one is fiber channel over Ethernet layer. It encapsulates fiber channels frames inside the Ethernet frames. The next one is Ethernet layer. It provides us reliable transport over a lossless Ethernet network using DCB features. This design ensures compatibility with existing fiber channel infrastructures while taking an advantages of Ethernet scalability. So what are the communication process? An application on a server generates a storage request. The converged network adapter, that is CNA, creates a fiber channel frame for the command. The fiber channel frame is encapsulated inside an Ethernet frame using the fiber channel over Ethernet protocol. The frame is transmitted across the lossless Ethernet network through DCB enabled switches. At the fiber channel forwarder FCF, the Ethernet frames is decapsulated and the original fiber cable channel frame is extracted. The fiber channel frame is then forwarded through fiber channel SAN fabric to the storage devices. The storage device processes the request and the response follows the same path back to the server. And another real-time scenario is here. Let's see about it. So imagine a large hospital data center that manages patient records, medical images, and the real-time monitoring system. Earlier, the hospital used two separate networks. One Ethernet network for general hospital applications such as patient registration, billings, and emails. One fiber channel SAN for storing large medical images such as MRI or CT scan files. This required two sets of cabling for each server, separate adapters, that is NIC and HBA, separate switch infrastructure, doubling cost and complexity. With fiber channel over Ethernet, each server is equipped with a converged network adapter. A single cable from the server connects to DCB enabled fiber channel over Ethernet switch. The switch forwards Ethernet traffic to the LAN and fiber channel over Ethernet traffic to FCF gateway, which connects to the SAN storage arrays. Now, doctors can access patient records and retrieve large imaging files seamlessly through one unified network. So what are the advantages of this? Reducing cabling and hardware requirements. Fewer adapter and switches are only needed. The next one is lower operational cost, less power, cooling and management overhead. The next one is the unified I/O, single network for LAN and SAN traffic. Next one is backward compatibility and improved scalability. In backward compatibility, it works with existing fiber channel SANs. In improved scalability, it supports growing the data center demand. So some of the limitations in this, what are they? It requires special DCB enabled Ethernet switches, and deployment is mainly effective in data center environment, that is short distance connections. Can face interoperability issues if multiple vendors are involved, and also transition from traditional SAN may need significant planning. So what is the conclusion of it? The main conclusion is that fiber channel over Ethernet architecture is a powerful approach to building a modern converged data center. By encapsulating the fiber channel frames over Ethernet, it merges the high performance and reliability of fiber channel with the cost efficiency and scalability of Ethernet. Organizations such as banks, hospitals, and the cloud providers use fiber channel over Ethernet to simplify the management, reduce infrastructure costs, and support high performance storage needs. I think the above topic is well known to you now. Thank you so much. Let's see in another video.